complete. Next, the stability of the submerged body. We have already given you the concept of the submerged body. The submerged body, it is inside that is the free surface. It is inside water. So in the case of the submerged body, the stability analysis. Stability analysis means we know equilibrium condition. Equilibrium condition. So body is at submerged condition. So inside the water, but it is at equilibrium. When it will be at equilibrium? When this W, the weight of the body having some weight here. Body having some weight. That is W. This W and the body is also displaced some liquid. The body is displacing the same volume of the liquid. The displaced liquid having the weight. And this weight will act in the net upward direction as a buoyant force. So the buoyant force is the net upward force. The buoyant force, net upward force. So W is acting from the center of gravity and net buoyant force is the center of buoyancy. So W should be equal to the FB. Then only body will be equilibrium condition. So weight is acting downwards and FB is acting upwards. That is nullify each other. Then the body will be equilibrium in the submerged condition. In such a cases as well as, so that is the net force balance we have made. Net moment balance. These two forces should be collinear. Should be collinear. If it is a collinear, so no problem about it. In the same line, the line of action is the same. If those two forces, the line of action is the same line, so there is no problem. So the body is perfectly equilibrium condition. Now we have to do the analysis that equilibrium having, so equilibrium, three types of equilibrium is there. One is the stable equilibrium, one is the unstable, another is the neutral equilibrium. So you might have heard about this thing. So one is the stable, unstable, neutral. What does it mean by the stable equilibrium? A body is at equilibrium. If you disturb its equilibrium slightly, it will come back to its own position and again further establish the equilibrium condition. Then this body is called the stable equilibrium. What does it mean? Here it is, this body is under equilibrium. Now if you give disturbance, if you give some angular direction, you tilt it and leave it. And check whether equilibrium is again established or not. If it is again established, we can say it is a steady equilibrium. If it is not established again further, so it is unsteady, unstable equilibrium. So stable equilibrium, unstable equilibrium. So here we have given some, here we have given some tilt. Some tilt is given. So now its condition is like this one. But the center of gravity will not change and center of buoyancy will not change also. Why? Because the gravity, center of gravity never changes here. Same mass is there. So gravity will not change. So now W is at here from G. And this center of buoyancy also will not change because it is under fully water. So the amount of the displaced liquid is the same. no change of the amount of the displaced liquid by the same volume. Just we change the is equilibrium condition. So the B point and G point, no change here. Center of buoyancy will be the same point. Why? Again, I am repeating, because there no volume, extra volume is come inside the water. Because total, initially also the full volume was inside the water, now also the full volume inside the water. So the amount of the displaced liquid initially, how much? Now also the same thing. But here, AB is acting downwards. Upwards. AB is upwards and W is. So what will happen? You give one tilt in this side, in this direction. That is the clockwise direction. You give a tilt in clockwise. So due to giving the clockwise tilt, the condition is like this one. Due to give the clockwise tilt, the condition is like this one. So now what will be happen? Now it is like this. So the force is like this way. AB is upwards and W is downwards, like the same one. So AB and W is the same from the equilibrium condition. So it tries to give one couple in this direction. Give one couple in the anti-clockwise. What does it mean? It means that it tries to again establish equilibrium, because I give one tilt in the clockwise direction, but the FB and W arranged in such a way it is given the opposite moment. So clockwise moment and anti-clockwise, again further another anti-clockwise moment will comes and it will give it this anti-clockwise moment, again make this body like this orientation. The anti-clockwise moment again make the body the same orientation, initial orientation. It will get back its initial orientation again further. So this kind of equilibrium is nothing but the stable equilibrium. So condition of the stable equilibrium. Here the condition of the stable equilibrium that is very, very important. P is center of buoyancy is above G. That's why it is happening. So the condition of the stable equilibrium for the submerged body is the center of buoyancy is above G. Okay. Now let you take here the B is below G. The B is at here and G is at here. Some G and B is below. The opposite. So here consideration. So B center of buoyancy is below G. So in the G, weight is acting downwards. Sorry, weight is acting downwards. Weight, and from B, FB is acting upwards. FB is acting upwards. Now you again give the clockwise tilt. This clockwise tilt is given by us to check what kind of equilibrium it is. But here it is balanced. W is equal to FB is satisfied also. It is satisfied. But after here, so G position will not change. G will not change here because center of gravity will not change. Mass is the same. So W is acting here at G, and B here, FB is acting. So what will happening here? The force will be like this. This side FB is acting, this side W is acting. So this will gives further one clockwise moment. We already given one clockwise moment. This arrangement is given another clockwise moment. So it will create instability. It will create instability. So this is the unstable equilibrium. So if B is below G, so this will create one instability. So it is called the unstable equilibrium. Because already you have given one clockwise moment, but now this arrangement, because the B is below G, this arrangement is given another clockwise moment. So this two clockwise moment will cause the body in instability. It will rotate. It will not come back to its initial position like previous. Okay. And another thing, if the B is at G, B and G coincide, these 2 points if coincide, this kind of equilibrium is known as the neutral equilibrium. So stable equilibrium, unstable equilibrium, neutral equilibrium. So the position of the center of buoyancy and position of the center of gravity is deciding factor here. So we have seen the 3 conditions. So if B is above G, stable equilibrium. This case we have seen previously. The B is below G, unstable equilibrium, just now we have seen, and B is at G, neutral equilibrium. Because it will not change. B and G position will not change, it will be similar like that. B is at G. If you have any doubt, I can show you again further, because the same point, W is acting in this way, and FB is acting in this way. If we give the tilt, the same way W is acting, same line, same point, FB is there. So the neutral equilibrium will not establish, it keep the condition in this way. No changes will happen after that. In this, that is the neutral equilibrium. So these 3 kinds of the equilibrium you have seen here for the submerged body. So the stability condition we have already we have told you, this stability condition, that is the center of buoyancy, the center of buoyancy, E is above center of gravity of the body. It is called the stable. Keep it in mind. Most important thing. So many questions asked in several exams. If B is below G, unstable. That's all the condition. If B is at the same point at G, is the neutral equilibrium. That's all the condition we are talking in here. Now we'll see about the floating body.